try the do now first, and then we're going to be talking about the graph tangent today. For the do now, first of all, it's just telling you to graph something. It's not giving you how much to graph, which means we should graph one cycle anytime it's not telling you how much. You're going to find your midline, amplitude, max, minimum, frequency, period, and then you're going to find your quarter points. So your midline is what you are adding on to the equation, y equals 1. Our amplitude is 3. If you're starting at 1 and you are going up by 3, you get to 4. If you are starting at 1 and you go down by 3, you get to -2. Make sure those values make sense when you plot 4, 1, and -2. Is your maximum truly your maximum? Is your minimum truly your minimum? Everything here is good. So I'm going to go and draw my reference line at the midline. Your frequency is found in front of the variable, which is 2, which means our period, 2 pi over that frequency, is going to be just pi, because the 2's cancel out. That means your quarter points is your period divided by 4. So pi divided by 4 is a quarter point of pi over 4. That means we have the quarter points pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And I'm going to label them out, and I'm going to space them out evenly. I'm going to space them out in sets of 3s just because I like my graphs to be nice and spaced out. If you need to, pause the video to write down everything. From there, we have a positive cosine curve, which means we are going to start at the maximum value and we are going to make a valley with 5 main points. So starting at my maximum of 4, going to my midline, come to the bottom, back to the midline, and end at the top. And make sure it fans out at the top. We want nice, smooth curves, but like better than what I just did. The next question, we have to talk about this one because a lot of people got it wrong on their test. They want to know where tangent is undefined. Tangent is equal to sine theta over cosine theta. So we do know that sine on a unit circle is y, and cosine on a unit circle is x. Okay? So sine is y, cosine is x. Now, when you take that unit circle, and we have a circle, we have the coordinates on a circle of 0, 1, because remember, a unit circle starts at the origin 0, 0, and has a radius of 1. So if you start at the origin and go to the right by 1, you arrive to not that coordinate, that's awful. And then of course it's not letting me erase it. Won't let me hide my mistakes. This is a bit ridiculous. There we go. All right, we're starting at 1, 0. If you were to go to the left, that would be -1, 0. If you were to start at the origin and go up by 1, that would be 0, 1. And if you started at the origin and went down by 1, that would be 0, -1. Now, something is undefined when the denominator is equal to 0. So we're really looking for where x is equal to 0 out of these 4 coordinates. X is equal to 0 at 2 points, up top and on the bottom. And we don't want x to be 0 because x is in the denominator, making it undefined. So what angle measure makes x 0? The angle measure of the coordinate up top is 90 degrees. The angle measure of the coordinate on the bottom is 270 degrees. So 90 degrees and 270 degrees make tangent undefined. Of course, if you were to use radians, 90 degrees is pi over 2, and 270 degrees is 3 pi over 2. You could also say negative 90, or negative pi over 2, or negative 270, negative 3 pi over 2. You could also include coterminal angles into this. So 90 plus 360 is 450, which will also end up top. So 450 degrees makes it undefined. Now, if you have pi over 2 in radians and you added a full circle, that would be 2 pi. That would now be 5 pi over 2, making it undefined in radians. And remember, when something is undefined on the graph, we have those vertical barriers that we can't cross, and those are called our asymptotes. So when we see the graph of tangent, it's going to have a bunch of asymptotes. They're going to be everywhere. Because of coterminal angles, you can keep going around the circle and hitting these tops and bottom points. So we're going to have an infinite amount of asymptotes. And when you approach an asymptote, you get really, 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 really close to it, but you never actually touch it. So this line, this arrow, is going to get infinitely close to pi over 2. But it's never going to be actually pi over 2, just super close. And it's going to go up towards infinity. So, recapping, an asymptote is a straight line approached by the given curve as one of the variables in the equation of the curve approaches infinity. I said that wrong. Approaches infinity. Anyway, basically, it's something that you approach but never actually touch. So, where are the asymptotes located on the tangent graph? At the values that make tangent undefined. So that's going to be like pi over 2, 3 pi over 2, etc. Now, the nice thing is that you really don't have to remember what this graph looks like. You're never going to be expected to graph this on its own. You are only going to be expected to be able to identify it. So sometimes they'll give you like a bunch of graphs and they'll be like, well, which one's tangent? You don't have to remember it because you have a calculator. And on your calculator, you're going to go to y equals. You're going to type in tangent x, and you're going to go to zoom, and we're going to specifically choose zoom trig because this is trigonometry. And it shows you what tangent looks like. It doesn't have the dashed asymptotes because you don't actually see the asymptotes. That's why we draw them as dashes. But it does show you what it looks like, so you never have to remember it. You do need to know how to analyze it though. So going on to examining it. Your amplitude is the distance from the midline to the maximum or the midline to the minimum. Now, your midline for a basic tangent graph, just like all of your other basic sines and cosines, is going to be y equals 0, unless there's a vertical shift happening. Now, going from the midline here, which is 0, to the maximum, well, what is the maximum? We have a graph where the arrow points up forever and down forever. So there is no maximum and there is no minimum. How are you going to count the distance from 0 to infinity? That's not a number. Infinity is a concept. You can't actually reach it. So there is no amplitude. The period, one full cycle, remember, it's where the graph starts to repeat. And if you look, here's one full cycle of the graph. That's what I keep seeing being repeated and repeated. So how long is that distance? That distance is from negative pi over 2 to pi over 2. That's a distance of pi. And if you were to think about it back on the unit circle, glad that my pen didn't change colors and it just erased on me. What is happening? Tangent is undefined up top, come on, and on the bottom. So this distance between two asymptotes, because remember there's an asymptote up top and on the bottom because that's where it's undefined, and that distance is half of a circle. Half of a circle, okay, it's just not going to let me delete it. Half of a circle is pi units. So the period is pi, or 180 degrees, but we're going to keep it in terms of radians because that's usually how we do trig graphs. Okay, this one's a little bit tricky. Your domain is essentially everything except for the asymptotes. So instead of staying everywhere where the domain is valid, that's a lot to say. We're just going to say where the domain isn't valid because that's not as much to say, it's less. So we're going to say the domain is all real numbers with the exception. Now remember, a domain is a set, so you would put it in set notation with curly brackets. My eraser isn't working though, so let's pretend that's curly brackets. Oh, okay, I don't know what's happening anymore. Anyway, it's all real numbers except this little line means such that. So it's all real numbers such that the numbers are not, we do not want x to equal an asymptote. And our first asymptote is pi over 2. Now, there are many asymptotes. There's also 3 pi over 2, and negative pi over 2, and negative 3 pi over 2. There's an infinite amount of asymptotes. You can't write all asymptotes down if there's an infinite amount of them. That's just not possible. So instead, we're going to give a formula to find all of the asymptotes. Now, notice that the next asymptote is a period away, and we just said a period was pi units, half of a circle. So from here to here, it is pi units. From there to the next asymptote, it would be 2 pi units. So all asymptotes are in increments of pi units away. So to get to the next one, you would need pi units. To get to the following 2 pi. To get to the following 3 pi. So we're going to say pi times k, where k is a value. So k could be 1, so just plus pi. Or k could be 2, plus 2 pi. K could be negative 3, where you are going negative 3 pi, 3 asymptotes over in the other direction. So that would be your domain. If that didn't scare you, which it probably did, you don't have to worry about that too much because I have not seen a question asking you to write the domain. If anything, it would come up as a multiple choice question, and chances are it would not be in that hard of a notation. I did give you the formal mathematical notation for it. The range is easier. The range is going to be your y values. How high does the graph go? How low does the graph go? It's still not letting me erase everything. It is what it is. Anyway, The graph has an arrow pointing up, indicating that it goes up to infinity. Also has a arrow going downwards, indicating that it goes to negative infinity. So this graph, basically, all real numbers. Goes up to infinity, goes down to infinity. For increasing intervals, it's increasing everywhere between your asymptotes. So let's find one increasing interval. Remember, increasing intervals means as you go from left to right, where is the graph increasing? Now, the only thing about this is that some people get confused because there are down arrows. The down arrows means that it's going down, but because the arrows are on the left-hand side, it means as you are going to the left, you are heading downwards. When we're talking about increasing and decreasing values, we're talking about if you're increasing or decreasing when you're reading from left to right. So as you head to the right, this graph, even though there's a down arrow, the graph is heading upwards as you head towards the right. This entire cycle is increasing even though there's a down arrow because it's increasing as you head to the right. So your increasing interval, the first one, is going to be the one in the center. That is from negative pi over 2 to positive pi over 2. Remember, you're not putting hard brackets because at pi over 2, there's an asymptote. So nothing's happening at that asymptote. The graph's not increasing or decreasing there. It just doesn't exist there. Another interval, and the U means, well, technically it means a union, but it means basically and. This and this and this. So another interval would be pi over 2 to 3 pi over 2. And you could create another interval if you wanted as well. You could create as many intervals as you wanted. I just can't write all of them down, so we're going to leave it at that. What is important to know is that the graph of tangent does not decrease as you go from left to right. There are no decreasing intervals. So a typical regions question that you're going to see about this is from 0 to pi over 2. The graph of the equation y equals 2 tan x will what? Now, you should know the graph of tangent will never decrease unless you have y equals negative tangent x, in which case that graph will decrease because it's a reflection. So instead of heading upwards, you're going to have a bunch of graphs that look awful like that. They're heading downwards. But again, that is for negative tangent, not positive tangent. Positive tangent always goes upwards. So don't choose choice 2 or 4 because they're decreasing, not increasing. We want to choose between choice 1 and choice 3. Now, as you go from 0 to pi over 2, this is a asymptote. And because it's an asymptote, that means as you get close to it, you are going to keep increasing forever as you're touching, or rather getting close to pi over 2. You don't actually touch it. So we say, instead of it's going to increase to infinity, we say it's going to increase without limit because it's by an asymptote. For example, if you see number 1, as you increase, as x increases from pi over 2 to 3 pi over 2, what will tangent do? This is a positive tangent graph. It will never decrease. Now, pi over 2 is an asymptote. 3 pi over 2 is also an asymptote. Remember, because pi over 2 is up here. 3 pi over 2 is down here. Both of these make tangent undefined. So because they are asymptotes, we're going to go, you can even see it up here, from pi over 2 to 3 pi over 2. The graph is increasing. And it's getting super close to the asymptote, which means it is increasing without limit. These questions don't really change much. So that's pretty much all you have to know about tangent. Just know the shape of it, and again, you can put that in the calculator if you need it, and know how to do these two types of questions. If you are approaching an asymptote, you are increasing without limit. Instead of finishing this worksheet, I'm going to go back to the day 2 worksheet. So head back to the day 2 worksheet, day 2, and you're going to scroll down to the bottom. Now, if you were in first period, you already know what I'm about to talk about, but I didn't get to talk about it with all of my classes before break. So if you scroll down to the bottom where it says phase shift, a phase shift is a horizontal shift. So a phase shift is a horizontal shift. That means we're going left to right. A midline goes up and down. So you might be thinking, here's your midline, that this graph is a midline of, gosh, I don't even know what I'm saying, that it's a sine function because it starts at the midline. But one can argue that's also a cosine function, if you think about it. So if I were to take a cosine function, here is a cosine function because it starts at the maximum, right? So I can make this look like it's this blue curve if I were to shift my maximum over just a tiny bit to the right. And if I shifted it to the right, it would become this curve. There we go. So I'm shifting my cosine function over, and now it looks like it's this graph, although I didn't shift it over well. Let's imagine that I did that. My point is, sine and cosine curves look very similar. They just look like a bunch of waves. So if you have the correct horizontal shift, you can make them overlap with each other. And those are called phase shifts because one phase it looks like a sine function, the next phase it looks like a cosine function. You don't really have to know too much about these, you just need to know how to recognize it in an equation. So recognizing it in an equation is actually pretty simple because you know that things go left and right when they're inside parentheses, and if they're outside of parentheses, they go up and down. For example, this right here is inside parentheses, so it moves left or right. Because it's in a parenthesis, it is a phase shift. And because it's positive, I'm moving to the left. If you were to have y equals 3 cosine x plus pi over 3, there is no parentheses. In fact, there's a hidden set of parentheses right there. So if there are no parentheses, or if there are parentheses and it's just, on the outside, that represents a midline. So this is up slash down midline. That's all you really have to know about phase shifts. If it's in parentheses, left to right. So in this case, you have something in parentheses, that's heading to the left as a phase shift. If it's outside of parentheses, that's heading downwards as a midline. So I don't really care about why this equation is y equals 3 cosine 2x plus 1. It's cosine because it starts at the maximum, and the maximum is equal to cosine. Your midline is at y equals 1. What I want to talk about is that it's possible to write this as a sine function. So we have y, this is not purple, still not purple. Guess we'll go with green. If you were to write it as a sine function, oh wow, totally ignore these directions. They are flip-flopped. It is possible to do it like that, but that is way too complicated. Anyway, when writing it as the alternate function, you keep the amplitude, that doesn't switch. We are flipping it to a sine curve. The frequency stays the same, and so does the midline. What we need to do is incorporate a shift left to right inside of parentheses. The frequency technically goes on the outside, and your phase shift is applied directly to the x variable. So let's look at a sine function. A sine function usually starts at the midline, and it goes up and then down. That would be a typical sine function. Now, our issue is that this doesn't really match up, right? So, our peak is here. Let me see if I could do this in blue. The current graph has a peak that is here. That's not blue, but whatever. And our peak of a sine function is here. So usually the sine function's maximum would be over here, and you want to move it to the x-axis. We're trying to shift everything to the left. The question is, how much to the left are you shifting it over by? This distance seems like half of pi over 2, which would be pi over 4. So it's left by pi over 4 units, which means you need to add pi over 4 to the equation. Now, number 4 was definitely a harder example of a phase shift. You are not required to know how to do number 4, so if that didn't make sense to you, that's fine. You should be able to recognize it. When you see it in parentheses, that means it's going left or right, and it's called a phase shift. That's all you need to know. And that is also all for this video.